Thank you for journeying into the wilderness to find Marilyn D. On this last day. We appreciate it. I know that they're like, I want to be at other talks right now myself, so we really appreciate it. So welcome to Spring Cloud on PKS. My name is Spencer Gibb.
Mauricio Salatino.
I am the co-lead and co-founder of Spring Cloud. I've been with Pivotal for about 4 years, working on all sorts of Spring Cloud stuff, and excited to talk about Spring Cloud Kubernetes today.
And I do work for a company that is called Alfresco. We do content management and process management, and we are currently modernizing the business process side and business automation tools, and we are building on top of Spring Cloud and Kubernetes as well. So,
Here's our legalese. Read it quickly.
That was fast.
Yeah, there we go. And today we're just going to talk, we'll give a little background about, a little bit about Kubernetes, a little bit about Spring Cloud and how they've met some of the cloud native principles. Mauricio will talk about the journey that his company and the demo that we're going to show kind of take from Spring Boot to PKS. Hopefully we can, the demo gods are with us and we can show a pretty nice demo. And at the end, I'll talk a little bit about the roadmap and where we see this headed in the future. So to start, Spring Framework has been around for a long time, and I kind of consider it the ingredients needed to use to build great applications. Been a Spring user for a long time. When Spring Boot was announced, I was so excited. Here's this opinionated way to build applications, especially as we start moving into microservices. So now Spring Boot, it manages our single process. But now that we have more processes, what do we do? So this was where Spring Cloud came to live. So we created some simple interfaces like service registry, service discovery, configuration. Where do we get our configuration from? Since then, it has grown tremendously. There's streams, Spring Cloud Contract for testing. We deal with tracing. Ryan here in the front talked about the gateway yesterday. So there's lots of great things in Spring Cloud that, help us eliminate the boilerplate associated with distributed systems, right? And some of the early implementations, when we first started, we were looking, I loved Ansi's statement from day one that Pivotal curates kind of the best of breed open source software. And when we were looking, some of the stuff that Netflix was putting out with Eureka was rock solid. We developed Config Server, which we modeled after, speaking with the Netflix guys, after their internal configuration server that they did not open source. We also integrated console from HashiCorp for not only service discovery and registration, but for configuration as well as Zookeeper. So as you make this journey into cloud native, there are a lot of changes that need to happen. Not only is it a technological change, but as we've heard from lots of the customers, it's also an organizational change and a cultural change, right? It can be difficult to change the way you've been doing things for years and years. As you start to deal, you want individual teams to move fast, but now there's things you have to overcome as you allow them to move faster, right? So we need to make sure that our contracts work together. We need to make sure that we can scale, and deploy independently. And part of that process is tooling and automation, anywhere from CI/CD. We've talked about Concourse and Spinnaker a lot here at the conference. Observability, Project Micrometer that is kind of the foundation for metrics and observability with Spring Boot, to things like Zipkin and tracing allow you to look at your system and see where things are slow. So this is it's a foundational shift from top to bottom, not just, hey, I want to deploy little Spring Boots all over the place, right? In fact, I was at a company once where we had split things up, but we had to deploy everything at the same time. So we had a distributed monolith, and it was, at one point it's like, hey, can we either finish or go back? Because distributed monolith is like the worst of both worlds. Right? Not only do we have all these services, but we have all the problems associated with the monolith too, and it's even worse. So big shifts that need to happen. So I really liked Dave Sires' slides from the keynote Tuesday, talking about the different levels of abstraction. And in the old days it was hardware, right? Your company built data centers or rented space somewhere. You ran on bare metal. Things changed, to VMs and now containers, and I have apps and serverless and all that stuff. Kubernetes comes and kind of takes advantage of the momentum of containers and creates a container. I don't want to say it's not quite a platform, but close, right? This container orchestration that allows people to manage their containers and do things with them that were previously very difficult to do. And it's kind of become the de facto standard, right? I mean, Cloud Foundry has had and used containers for years. It was built on containers. But the popularity and the availability of and the community surrounding Kubernetes is such that customers, we like our apps on PKS, but we also want this thing. We have these other workloads that don't quite fit Pivotal Application Service, and they do fit in a containerized world. So PKS came along, and there are a lot of benefits to PKS, right? It's managed by Bosch, so you get that same day two kind of manageability that you have gotten with Cloud Foundry for years. Some of the high availability and everything managed for you. So it's a great addition to the platform. And so we've been looking, other companies have been looking for a long time. How can we take advantage of that? How does Spring Cloud fit into this world?
Yep.
So Mauricio is going to take you a little bit on a journey here.
Thank you, Spencer. And and this journey, it's all about this, right? So I'm a Java developer, right? And I am in charge of this open source project, and we are trying to go from what we had before. We had a monolith, just trying to go to a cloud native approach. So we started looking definitely into Spring Cloud. But we knew from day one a year ago that we will target Kubernetes as our main deployment infrastructure and platform. So this journey has been extremely interesting. We have been learning a lot as a team into how technology is applied, how the industry is changing, how conventions are coming from these communities that we just need to take on. And I've been collaborating with Spencer here just to make sure that we have all the abstractions and all the implementations in place to run stuff on top of PKS and Kubernetes. So this journey, and the picture here is a band from the 70s. If you go to Wikipedia and look for this band, you will see one of the most hated and one of the most beloved bands from the 70s, which is kind of like how the journey feels. But at the end of the day, we learn a lot. There are a lot of tools coming out of these communities, and you need to keep an eye on those. So quick disclaimer about the starting point, right? We started with a monolith. We had a monolith that we wanted to take it to Kubernetes or a distributed environment, a distributed system, and to enable other customers and community users to integrate with this service, that big monolith that we had. It was extremely complicated. So we took the core bits of that big thing and we started migrating those to cloud native building blocks that people can start using. So of course, we started with Spring Boot, and again, it's as Spencer mentioned, I mean, Spring Boot and Docker, they have a relationship there, right? So you have Spring Boot service, you can definitely containerize that, right? But the problem that we faced at the early beginnings was that, okay, so we have a service, but you have also a lot of other things around that service, right? Like infrastructural kind of things. You have databases, you have message brokers, and you definitely need to define the boundary of your service. You can definitely mock a database or use an in-memory database, or you can mock the streams as well. But in reality, if you want to test or do integration tests, you will need to use as well containers in order to test your service against that, right? So for integration testing. So we went through this journey of saying, okay, we want to use Docker for all these other infrastructural things. So we created Docker Compose files to bootstrap these services and enable our developers to interact with those services and to be able to replicate these environments for all the team members. That was kind of like a good first step, and then we started using some Maven plugins to automate all this process so you can start containers and test your services against those containers. It was kind of okay to get things up and running, but we quickly move away from that. The next step on the Docker journey was to start learning about, and you need to spend time, like developers need to spend time learning about how Java behaves inside containers, right? I think that we all gone through, if you are looking into containers, you need to go through that learning phase where you said, okay, we need to set these flags depending on the JDK version that we are using. We need to configure memory allocation in this way if we are running in containers. So all those things take time, and we spend quite an amount of time on that side. Because we were starting like in this kind of like, so we had a monolith, but we started all these projects in separate repositories. I'm showing here, we try to follow these conventions as much as we can, like one service, one repository, right? So if we have one Spring Boot application, we just try to put it there in a single repository. Repositories in GitHub are free still, as far as I know. But it's kind of like easy, and you keep the responsibility close to that repository about that service. Then you need to deal about with the dependencies from that service, right? So if you are building libraries that your service depends on, then you will need to make sure that you have pipelines to propagate those changes. And then, of course, you need to start creating Docker files, right? In order to create your Docker images and containers, right? And again, choosing the base layer image, you definitely need to choose that. And what we start realizing is that then these kind of decisions were like pushed back to the developers. Right now, we as developers will need to define these kind of things. And that also makes us think that, as companies needs to have policies in order to define these and certify these base images that all the microservices or all these services are going to use, right? The next step, of course, is that you create a Docker file, and then you need to publish that Docker container somewhere. Again, on the developer shoulders, you need to say, okay, where? We are a Java company, so we already had our own Nexus, and we also deployed to Maven Central, right, like our Java artifacts. But we didn't have any policy whatsoever for Docker images and containers, right? So we need to make another choice there, and it's a hard choice, and it takes time again, right? So we started deploying things to Docker Hub because we are an open source project, so we can create images and publish, them publicly there. But if you are a company, then you need to decide which service or which registry are you going to publish to, and if you want to pay, how many repositories and all that stuff. Because we had one service per repository, that means that we will have one container per repository as well, so the relationship is quite simple. But then you need to start dealing with maintaining those Docker images and labeling and, and making sure that, you tag them accordingly every time that you release. So it gets much more complicated. The second snapshot here is Harbor, the one that we are going to show today in the demo. It's another Docker registry that comes with PKS, and it's just a tile that you can click a button and get the new Docker registry set up for you, and you get it for your projects and your Docker images, right? It provides scans and a lot of really interesting stuff. Next step is like, okay, so we can build our own services separately, but as Spencer mentioned, when you have multiple services, then you need to have a programming model that allows you to build, using cloud-native patterns, right? How do you glue all these services together to work in a robust and resilient way? I totally recommend these 3 books in general, like as a starting point. Mostly I use these books with my team because they give you like different aspects of the problems that you're going to face and different patterns that you can use in order to solve problems. Building microservices, very high level, but showing patterns, like cloud-native patterns that you definitely need to learn. The second one, very practical, right, using Spring Boot and Spring Cloud as well. The last 2 chapters cover pipelines and Cloud Foundry, right? Unfortunately, it doesn't cover Kubernetes, but that's the next step that you need to go through on your own. And the last one, it's more theory, right, and patterns as well, and also talking a little bit about the organizational change that Spencer was mentioning before, which is extremely important, right?
I think 3 out of the 4 authors were at the conference this year.
Yes,
so.
Of course. So that's it. You are in the right place.
Yeah. So along that journey, now we can go back to this.
Yep.
Yeah. Now that you come to Spring Cloud, and we've talked a little bit about some of the things that Spring Cloud provides us, and we're going to cover a few of these today as we talk. Specifically, we're going to talk about configuration and discovery, and a little bit about Gateway, how it uses both of those pieces. But Spring Cloud has just defined these abstractions that allow you to implement these patterns. And I saw a tweet the other day that said, running Eureka, we're not going to talk about Eureka from Netflix, but running Eureka with Spring Cloud is just so simple. And I was so happy. I was like, that's what, Spring Cloud for me was making some of these things that if you had to do them on your own, can be very difficult and very frustrating. But we try and make it simple and easy, with some minimal configuration to get running.
Yep. Yeah, totally. And for us in our project, the Spring Cloud, when we started, it's kind of like that sensation. It's like, Spring Cloud Eureka, the implementation or console, and the configuration server, right? So when I go to different conferences, that's basically what I'm getting from people. But in reality, if you are serious about building cloud-native applications and our products on top of these technologies, all the set makes sense, right? Because it has been built using these patterns, and putting all these components together makes sense and help you to build more and more robust applications. So that was kind of like a good discovery for us. And looking at different communities, there are different people implementing this kind of stuff using all these components in general. And you will see diagrams like this, right? I didn't want to show our project diagram, but our project diagram looks pretty much the same, where you have a gateway, in front of all your services. That gateway is automatically registering routes to the services that you're going to put inside that green box in the middle. You have a Eureka server for discovery and configuration server. And the gateway is integrated with some kind of security mechanism for single sign-on, right? The moment that you have multiple services, then you need single sign-on for all those services, propagating the security context all over the place. And then on the bottom, you have monitoring, right? Again, if you take a look at these communities, this is the JHipster community. They are building stuff in this way. And this is becoming, again, kind of like the de facto way of building cloud-native applications. And when you look into Kubernetes, Kubernetes is pushing the same pattern. So we will end up with something pretty similar there. Different implementations, but similar structure. Yep. And communities like these ones, and we also started going through this journey with Docker Compose for our consumers, right? So we start getting into these conversations of, okay, if I want to try all these services all together, how do I start them all at once with a single command? So you can write a Docker Compose file with all the services configured to talk to each other and all the security configurations in there, so you can quickly bootstrap everything. But at the end of the day, Docker Compose doesn't provide you all the things that you're going to expect from a cloud-native application, so it kind of starts all the services, and that's pretty much it. You cannot handle, restarts or, health on the services. You just need to deal with that on your own. And even if that's good for a quick start, it's not good for the long run. So we quickly move away from that, saying, okay, if we are targeting Kubernetes, let's do it the Kubernetes way. So next step in the journey was Minikube, right? And again, Minikube is a single node cluster installed in a VM inside your laptop, which sounds like very good because it's a Kubernetes installation at the end of the day, and you can definitely start playing with the Kubernetes concepts, right? Again, for a Java developer and for a team of Java developers, learning about these concepts, it's extremely important. So you need to have a playground for that. Learning about what the service is, a deployment is, a replica set is something that you need to feel comfortable in order to start using them and understanding how they will work, right? But in reality, again, we move away from that because, again, as soon as you start deploying 10 services or 10 containers into there, it gets tricky with memory, it behaves differently. So we wanted to definitely use Kubernetes, a Kubernetes installation, any of the flavors, right? That's why we started looking into PKS and other providers in order to understand how this will work. And then it's when we start looking into this, some mismatches between Spring Cloud and Kubernetes, mostly coming from, people that knew already Eureka and the configuration server, that they were start saying, well, but Kubernetes already automatically registers services, and it uses a DNS-based approach in order to do that. So how can we leverage that from the Spring Cloud, and how we can let Spring Cloud deal with that in a Kubernetes environment?
So when a while ago, actually, Ray Tsang and I started talking about when Kubernetes was starting to talk about, he really like Spring Boot and Spring Cloud, and so we started talking, and we actually thought about, maybe let's do a talk last year about implementing some of these Spring Cloud concepts, and our target would be Kubernetes, so we started playing, and we started, doing, so like you talked about, Eureka has a couple of functions, right? You register your service with it, and then other services can discover it. Well, on the Kubernetes side, registration is implicit in the platform, right? So we don't need registration from Spring Cloud, but discovery would be interesting. Yep. Config server serves up, configuration, and like you showed on the slide a couple slides ago, Kubernetes has config maps, they have secrets, they have ways to expose configuration to your application. Well, maybe let's try and use the Spring Cloud Bootstrap, which is how we go out to remote services to get configuration. Maybe we could plug that in. So we started playing. Apparently at the same time, another group also started doing almost the identical thing. And they actually went a little further than we did, as I had to continue maintaining the other parts of Spring Cloud, and they were able to move it along even further, and they got in contact with us and said, hey, we've done all this work, we think it might be useful, do you want it? And we said, yes, we do. And so we replaced what I had done with what they had done, and we put it in our incubator for a while and let it incubate, let it grow, and see the community around it. And there was quite a bit of activity and interest. And so we've decided to bring it into Spring Cloud as part of this upcoming release train. We'll talk a little bit about that. But so what we're going to focus on today are those implementations of the Discovery Client from Spring Cloud, and also plugging in configuration.
Yeah, totally, and that's definitely why I got involved with this project, Spring Cloud Kubernetes, because we started a year ago with the very earliest snapshots for Finchley and Spring Boot 2, and we decided to say, okay, let's go ahead and try to collaborate to this Spring Cloud Kubernetes project to move it to Spring Boot 2 and to Finchley, so we can start using it right away. And we have been going back and forth with Spencer and the group just to make sure that we have everything that we need in there to be able to deploy cloud-native applications on top of PKS and Kubernetes in a simple way, right, to use all these features. Along the journey, you will learn Kubernetes is like YAML, so you definitely need to learn the concepts plus how to represent those concepts in YAML. And again, based on conventions, yeah.
If you weren't a YAML programmer before, you
will be now. Yeah, now you are a YAML programmer. Get used to that. But the good thing again is during this journey, we found more and more tools that create this for you, basically. And then you need to learn how they work, but at least the generation and typing, all that stuff, it's no longer needed. Next step on the journey is you will have a lot of YAML files with Kubernetes deployment descriptors, but you can use also Helm in order to package all these descriptors using template mechanisms to be able to distribute your applications, in a simple way. So you have Helm charts for that, and it allows you, I'm showing here like one of the gateway Helm charts that we have here, but you can have composed charts and hierarchical charts that allow you to deploy tons of services at the same time, providing the configuration for all those containers. And then that's why PKS becomes really, really handy, because it allows you to take Helm charts, create tiles that you can distribute in a marketplace, and some other people can use the stuff that you're providing, right? So you can create a Helm chart, publish that, and then you can install PKS and install this chart or Helm chart or tile extension that will be automatically deployed to your Kubernetes instance based on your configuration for your cluster. So that's very, very useful and handy. And then, of course, we should be prepared for that way before in our journey. We started kind of late with CI/CD, like double CD, continuous delivery and continuous deployment. And that's extremely important. What we have learned in the last 4 months has been huge. Most of the time, it's related to, okay, what's the methodology that you need to use in order to push, these kind of applications forward and to be deployed in something like PKS. We have been using this project, and again, this is a recommendation from my side. In my personal opinion, this is a very good project because it definitely understands about all the journey that we are going through. This project is called Jenkins X. One of the most common misconceptions is to think about Jenkins because the name is the same. But as you can see here, Jenkins is just a small bubble like in there. All the other things around that, it's the glue that you need in order to put, source coming from Git, Maven builders, like using build packs, then Helm and Docker all together, right? These guys are also very interesting because they are taking things from all these communities, like the Kubernetes community, the Knative community, the Jenkins community, and all the expertise from all these fields, and mixing it in this very like agile kind of platform. So I've been using this for the last 4 months only because it really matched all our journey, right, and the technology and the things that we were doing. They were basically automating all those things. You are free to use any tool that gives you these kind of things. And the key takeaway from the demo today is that if you are looking into deploying into Kubernetes or PKS, you should be looking at tools that provides all these kind of things for you, right? One of the important things that these tools also provide is using a GitOps approach, which basically allows you to have your environments defined in a Git repository that you can quickly restore and recreate in different clusters. So I guess that's demo time.
Demo time.
Yeah.
So let's talk a little bit about what we're going to show here.
Yep.
So as you can see, so I'll let Mauricio talk about the application itself, but as far as the environment goes, this is PKS running on GCE. I had the privilege, I guess, of getting that running, and take it from me, you don't want to be doing this yourself, right? Getting PKS and PCF running is non-trivial, but once it's up, using it as an application developer to deploy your applications to is fantastic. So we will plug into Kubernetes for service discovery, for config maps. We'll show that how both in the gateway and as the other services talk to each other, how that works a little bit. And show some pretty neat things with dynamic configuration and updating the config maps. We'll see some interesting things there. And all the apps you see are Spring Boot applications. If you want to talk a little bit about more how the app works.
About the app itself, right? So we have a gateway that's going to front face all of our services. We have a concert service that it's pretty basic. It's just give you a list of concerts. You can create concerts. We are storing, the concerts information inside the MongoDB, nothing fancy. And then we have the ticket service that basically it's associated to one concert, right? So the idea is that you go to a concert sites page, you list all the concerts, and then you can click in one concert and see how many tickets available for that concerts are, and you can buy the tickets in there, right? Now, what we wanted to simulate here is the fact that different concerts will have different demands, right? So you should probably tend to separate those concerns and say, okay, we can quickly list all the concerts, but when people want to buy tickets about a certain concert, we will just delegate that to the ticket service, right? So in this case, the concert service is going to do some discovery to find out which ticket service it should use in order to sell tickets for that. And it also will be doing some decoration on the concert information, right? So if you call a you try to get the information about the concert, and there is a ticket service available for that concert, we will just decorate the concert information with the available tickets. So that's what we are going to try to show. And as you can see, we have the gateway, the concert service, and one ticket service already deployed.
That's what the green checks are.
The green checks are, yeah. So
deployed.
they are already running, right, in a PKS instance. And what I will try to show, and again, demo gods needs to be on my side because, as I mentioned before, the journey is quite long, so tons of things are happening. But if everything works well, I should be able to get another ticket service instance deployed. And I will start from where is it? Let me go out. I will start from the initializer page, right? So I will come here. The first thing that I will do is I will just create a Spring Boot application. Yep.
Everyone's familiar with Initializer, right?
Yep, all familiar with this. Yep.
Josh's second favorite place on the internet, right?
That's the idea. And yeah, and I will add very,
Jar, not more. There you
yeah,
go.
very simple stuff like web, actuator, a Spring Boot admin client because I want to monitor the application and list it in the dashboard, and then security for the same reason. Let me do one more thing. I will just change this name. Let's do with Journey. And I never tried this before, so if it fails, we will see. So I will just switch to that downloaded zip file. I will just copy that, and the next thing that we should do is we should do some coding, right? So I will open the project in my IDE. And again, very simple Spring Boot application, nothing fancy. We will not change any dependencies for this application itself because we don't need this application to do anything, right? But the only thing that I will do here is I'm just going to add a Maven plugin, right? So I will just extend this Maven plugin to generate some information for when I deploy this application, I can monitor it. I will do the same here in the main application, right? Spring Boot application, very simple, nothing fancy. And I will add some security configuration here as well. I will auto-generate that. I will import all the things that I need, right? I need that one as well. Yeah, so okay, close that one. And we need to create, yeah, and I will just create a simple REST, REST controller with just a single endpoint so we can get the available tickets for that, right? So get mapping. Yeah.
He's going to live code a database on stage. Watch.
Look.
It's coming. It's amazing. I've never seen anything like it.
How many tickets do you want for Journey? 300.
There you go.
That's kind of like a lot.
Database is coded.
Coded.
How is that?
Yeah, done, right? One more thing that we need to do here is just add some configuration here, right? For, again, endpoints and actuators so they can expose information and that can be consumed. And I think that that's pretty much what we want, right? That's the simplest application that we can create with Spring Boot. We didn't add any dependency besides, the monitor thing, the client side of things, web, security, and the actuator so we can monitor what the service is doing. So the next step is just to go to that, right? So remember that until now, I've just downloaded a zip to my computer. I have nothing else. I have the project. And usually, if I'm going to try to create a pipeline for that, I need to put that into GitHub or in any Git repository, right? And again, because I'm using Jenkins X, the only thing that I need to do is doing a JX import. And this basically, it's going to do all that for me. So it's going to do a bunch of stuff. And it's going back to the journey that I was mentioning before. It's going to generate all these descriptors and things that I need in order to get from Spring Boot to some service up and running inside Kubernetes. The first thing that it asks me the user where I want to create that repository. So it's going to create that in my GitHub account, right? So I've already installed all these tools and configured those tools to do that. So the import process is done. So I can go to the UI, basically, to see the pipelines. And you should be able to see that now I have a new service and a new pipeline running for that service. That pipeline knows what to do in order to do all the deployments, right? I will stop it just a second, and I will restart it again in a bit. But I just wanted to show you all the files that were generated, right? So now we have a pipeline that knows how to take from that source code, going through creating a Docker image, publishing the Docker image, creating the Kubernetes descriptors, publishing the Helm charts into a repository, and deploying the application into a namespace inside Kubernetes. And the only thing that I needed to do here, I just needed to tweak a little bit of the memory and CPU parameters and allowance for the application to run, just to run okay. I just don't want to struggle with memory or CPU, right? So I will just change that a little bit. And then I will just add one more thing, which is the labels that we will explain a little bit more on that later on. So I will just add some labels to my service, so when I do discovery, I can find stuff based on those labels, right? So I'm going to change these, and we can put journey here as the code. And this is YAML, so you need to be extremely careful about the spaces. If something is wrong, the linting process of the templates will fail, so I shouldn't be that worried, but I just want it to work. So now I made a change in my project, right? And I've stopped the pipeline, so the pipeline is not running. But as soon as I do a commit on top of that repository, the pipeline will be retriggered again, right? And again, the important thing of this is that we are just trying to go from having a Spring Boot application to something that is deployed, but also we want to have CI, CD on top of this project, right? Like continuous integration, continuous deployment, and continuous delivery for that.
And like he said, he's familiar with Jenkins X and roll with it, but there's been a lot of talk about Spinnaker that provides a lot of the similar functionality. Will trigger a build and deploy from Git. So similar types of things.
Yeah. There are
just something to do to automate this, and so that you can get visibility into what's deployed.
Yeah, and how important that visibility and having all the tools and understanding about the tools is for the entire team. Because if you don't know what's going on, then troubleshooting this kind of stuff gets quite complicated. So visibility is extremely important. The pipeline was triggered, right? It's there, it's running. So now we can switch back to explaining a little bit about more of the applications, right, that are already deployed.
So we're going to do some hand waving here because
pipelines
take a while, right? It's going to do things like create Docker images, download all the different layers of that Docker image, and then upload them into Harbor and that. So it takes a few minutes. So while that is working, I get to talk a little bit about the gateway that we're doing. So again, this is already deployed, but we're just using the latest Finchley release. So we have our Spring Cloud that we're importing. Pretty standard application, just like he talked about, actuator, configuration, gateway. So what is kind of new here that's similar to the other applications that we're using discovery from Kubernetes and config from Kubernetes, as opposed to previous demos, lots of things you'd usually see Eureka and config here, right? So these are analogous, but are pretty interesting. So the application is dead simple, like lots of Spring Cloud demos, right? It's just an application with an annotation. The interesting thing on this particular slide, or this particular configuration, is that we have enabled polling of the config maps, so that when a config map gets updated, that we can see those changes reflected automatically in the Spring environment.
Labels,
yeah, so here we have our one of the things that when I created the gateway was I wanted discovery to be something that you opted into, where in Zool it was opt out. And one of the things that was interesting, especially in conversations with Mauricio and others, is that not everything that you register or that gets deployed into your platform you want exposed on the edge necessarily. So I came up with an idea of being able to filter those things that are registered by their metadata. And so here you can see this this filter, and this is Spring expression language that we handed a services instance from Spring Cloud Commons, which has a metadata property. And so you can say things like only expose things, in this case, that has a piece of metadata that matches that particular S1P label. And we've also changed a little bit what the route looks like, where you're headed when you route. And let's see, the last little piece we wanted to show here.
Yeah, labels. Yeah.
Were the labels, if you want to talk about those real quick.
Yeah. So basically, again, as Spencer mentioned before, when you are in a Kubernetes namespace, you will have a lot of services being automatically registered there, right? As I mentioned before, we are storing the concepts in the MongoDB database, and that itself, because we are using a Helm chart, it's creating a service for that so you can access it, right? It means that if you want to do automatic discovery of services, you will see the MongoDB instance in there, right? The main problem that you have with that is that when you go to all the tools that were built to monitor, for example, Spring Boot applications, they will not know what to do with the MongoDB instance that is there. They will recognize that there's a service, but that service will not have any actuator to get information about that specific thing. So we are setting different labels to the different applications so we can use the discovery clients to filter automatically the service that we are really interested into, right? We have that label, which is called a Spring Boot True if it's a Spring Boot application, right? So for all of our Spring Boot applications, we have that. And you can tweak that, and you can put any name that you want in there, right?
Yeah, so basically it allows you to, on the discovery client side, basically have a subset of the things that are registered as services in Kubernetes. In this case, we're doing Spring Boot True. It could be microservice equals true or something a little more generic like that, so that, you know, obviously all your microservices don't have to be Spring Boot, but we would like them to be. So you can get that value out of Kubernetes. Yep. So we need to check on our pipeline.
The pipeline is still running there, so let's jump to the concert service. I want to quickly show you a little bit about that as well, the kind of things that we are doing inside the concert service. And again, a couple of things that you will notice here is that we are using the Spring Cloud common interface, the DiscoveryClient one, in order to do discovery, right? And then the question becomes, right, like when you go to presentations like, Istio and Spring Cloud, Spencer did one about that, and yesterday there was a very interesting Istio presentation. You can do DiscoveryClient with these other frameworks, right, and platform-related things, but this is a little bit more, at least I found it really, really useful when you start doing real-life stuff that you need to do some more business-oriented discovery, right? When you need to bind services that it's not clear, even if you know the name, maybe you need to target a specific instance because you want to talk to that one. So what we are trying to demonstrate here is that kind of binding on metadata and discovery on runtime of things that are happening and things that are getting deployed, right? So what this service is doing is also loading a configuration. This is a Spring Boot, like a Spring configuration, like basic one. But again, the trick, as Spencer mentioned before, is that we are loading this configuration on bootstrap time from a config map. So we implemented a very, very simple feature flag in one of these methods that says that, if you're asking for all the concerts and we enable this feature flag, we are going to decorate the entire list of concerts. If that feature flag is not enabled, we are just going to decorate whenever you ask for a specific concert, right? So if you take a look, the only thing that we are doing is we are using web flags, and we are just we are using the web client in order to decorate that. So if there is a service available for the tickets for this specific concert, we are just going to do a web client call to that service, and we will just setting up the tickets that are available for that specific concert. So I wanted to show you a little bit about the service itself. So I can clean this up, and we can do something like getting the concerts, right? So we have 2 concerts. As you can see, there is non-available tickets because by default we don't have the decoration on the list. But if I go and I get the concert, the specific concert that I have already deployed, you can see that the service is being decorated with the available tickets, right? And I can see green on the pipeline on the back. That means that I should be able to see now a service up and running in my namespace, in my Kubernetes namespace. It also means that if I go to the other concert, right? So if I go to the other concert, this will not work because I need to do something else. Yeah, if everything is binded, right, I should be able to get that decorated as well, right? And the only reason why it's not working is because I have a band called Journey, right? And it has a code, a specific label that it's called Journey, and this code is not matching, right? So what I can do is I can create another concert for Journey in particular. So that's exactly what I will do now. Where I have some other JSON files, so I will copy this one, right? Yeah, so JSON to Journey, JSON. Typing on stage is not easy, right? That's it. And let's say that this is Journey. Yeah, there's one. Right. So let's leave that there, and I can do HTTP post to get the concerts URL. And I can do journey JSON, right? Yeah. Typo there. Sorry about that. So I have that. Now I have journey, and I have the code that it's going to match with that, so the discovery client should be able to find that. If I do that guy now, if I ask for that guy with the ID, I should be able to get the 300 tickets there. So the binding is happening there. It only happens because it found the service that was automatically deployed there. And then the next thing that we can do is play a little bit with the config maps. So we can try that feature flag that we have there, right? So now the list is not being decorated, right? But we want to be able to test that, so we can definitely do that. In order to do that, I need to switch environments. Again, as I mentioned before, Jenkins X has different environments. So I will switch to the staging environment where my services are running, right? And as part of all this pipeline, I should be able to see that, get pods, that there is a pod there available. We should be able to see it there. That's the pod that it's running. And one of these services, the concert service, is also defining this config map, right? So if I show you that as well, this is a config map that it has that flag, right? That's application property defining a property. By default, is false. So I should be able to go and change that using the pipeline. I can change the code, commit the change, and it will go through the pipeline and perform that change. Or I can go to the resource that it's running in Kubernetes already, get the config map, and change that live here. So if I do this guy here, and I edit that descriptor, I should be able to change that. Again, because we have automatically reload on the config maps and secrets, this is going to automatically refresh the context on the Spring Boot application. This needs to be true, right? And then I can just go and query again the concerts, and you can see that this one was decorated, and the other one that has a service has been decorated as well, right? So this is pretty slick because, again, you are working with Kubernetes concepts and modifying the information that the Spring Boot applications are getting. And again, it's really important to understand that this is kind of like a very long journey. The other, yeah.
So basically what happened there was that they were pulling the config map, and what happened was essentially, for those of you familiar with Spring Cloud config, you can call the refresh actuator endpoint, and it will refresh your go out and get it. So the polling just automatically did that. So there was no intervention needed; it just happened. So that was the automation that happened there. So.
Yeah, totally. And we can show that as well, right? If you want.
Yeah.
Do you want to show that? Yeah. So basically, what the Spencer is saying is that we can do something like get pods, so we can monitor what's going on inside the pod. I will just make it very bigger. Don't give me a second. So, right, so those are the logs. I can make it bigger. You will see a lot of logs. And that's the context, right? That's the application saying, okay, it was started, it was refreshed. So if I go now and turn off that flag again, right? The moment that I save the descriptor, it's going to be applied, and at some point, we will see that the context of the application gets started. Oh, it wasn't this one. Sorry about that. Sorry, it's the concert service, which is here. Yeah. Yeah, you can see there the refresh of the context. So let's do that again. Let's modify that. Yeah. So this is, for us, it was very interesting to play around with this because we are using all these features, so that's refreshed based on that. So it's kind of fast. It took like half a second.
Great.
Yeah, great stuff. So one more thing that I want to show.
Okay.
One more thing that I want to show, it's related to some, again, concerns about security, right? Now we are using Spring Cloud Kubernetes, right? It is using the Kubernetes APIs inside of our pods, inside of our containers. That means that there is it's not a security risk, but you need to be aware of security, right? Now we have pods that can interact with the cluster APIs, right? In order to enable pods to interact with the cluster APIs, you need something that is called service account. So basically, you can say to your deployed services, okay, this service is enabled to do some interactions with certain set of APIs, right? So for example, for the gateway, we needed to enable the gateway to say, okay, give me all the services that are available. And that's a call to the Kubernetes internal API. So we need to create these three, YAML descriptors. Again, that's the service account, and it's templated as well. The role binding that basically allows you to say, okay, this service account can be binded to these definitions. And then the role, which basically lists all the things that you can do with config maps and service and endpoints. This is a pretty large permission set, but it can be restricted very, very narrow, right? So that's an important point, and it took us some time to understand the situation that we were facing. Like now we are enabling a pod inside like a container to interact with the Kubernetes cluster from inside.
And basically this allows the discovery client and configuration to access those APIs and do what we have just shown, right? That's what he.
Yeah. One more thing is the Spring Boot admin application. We tried to collaborate with this application because we thought, okay, it's cool. We are deploying a lot of Spring Boot applications. It will be really nice if we can use the same discovery mechanisms that we are using outside Kubernetes for this application. So we modified this a little bit in order to use the discovery client coming from Kubernetes, and then everything works, right? We haven't changed anything of this application, and the entire application is working. There are a couple of details, of course. For example, here we are listing the IP, the internal IP for the nodes inside the cluster, meaning that I cannot click there and access that, right? I can access to see all the things because this application is also running in the cluster, meaning that I can get all the metrics and all the information that I can get because the application is configured to do that. So yeah, you can see all that stuff, you can see all the threads, everything that is happening there. And again, because it's working with this reload capability, every time that I deploy the service, I didn't need to do anything for this new service to appear there in the application. And I think that that's kind of cool, and it demonstrates the concept of, again, using Spring Cloud abstractions and just providing different implementations into the class path and just tweaking a little bit the configurations in order to make sure that all the applications that were designed to work with the Spring Cloud can work inside Kubernetes and reuse all the Kubernetes internal services almost out of the box, to be honest. Yeah.
Yep. Yeah. It's kind of neat to see these things happening and fulfilling visions that we had a number of years ago.
Yep.
So pretty neat.
Yep. And again, we were using Harbor, so if I refresh the Harbor registry, I should be able to see the new service there. That's the new Docker image that you can reuse, share with your teams. The same for Helm charts, right? So a new Helm chart was deployed here. And basically what it means is that in our environment, we have just now a new dependency to that Helm chart that is going to be deployed in the staging environment. And then if everything works well in staging and we have tested the staging environment, we can just promote that to the next environment, which is production, right? Or create our custom environments.
And again, Harbor, when you get PKS, Harbor created by VMware in partnership with Pivotal so that you can have a private Docker registry as opposed to going out to Docker Hub or somewhere else public. So all secure, all inside here, and provided by the platform and managed by the same thing that manages PKS and PAS.
Yep. So the interesting part, I guess.
So,
yeah.
So big announcement. Spring Cloud Kubernetes. We've had it as part of the snapshots of Greenwich, which is the latest in our release train for a number of months now. We moved it out of incubator, and it's available today. Yeah. We get to announce the release here at SpringOne. There will be a blog post coming soon, a little bit more about this release. So tentative plans are basically to follow the Spring Boot 2.1 kind of release. So we'll have hopefully an RC in mid-November, and then try and release before the end of the year so that you can get your hands on this. And we're starting to think about, what else can we do with this? Where are we going with this? We've talked about Istio. We've talked about Knative here at the conference. What can we continue to work with those? Can that work? And what might we need to change to work with those. And Mauricio has created a bunch of these if you want to chat about any of those.
Yep. Feel free to reach me out and talk with Spencer or myself because we definitely know what the path is, right? So because we are building a real, set of building blocks that will need to consume these things anyway, and we see, the industry is going to Knative, is going to Istio. So how do we make Spring Cloud better on top of these platforms and with all these features, right? So Spring Cloud Functions is something that it's in my to-do list. There are some other more basic things like, for example, distributed timers when you're running in Kubernetes. We want to provide out-of-the-box supports for these things. And again, it's something that I need, so I'm quite committed to deliver. I need to deliver or I will get shot at some point. And Kubernetes Service Catalog integration. These are kind of things that the Kubernetes community is using quite heavily. When you go to a more polyglot environment, people is already using that. And we know that the support in cloud providers for these kind of things, and for example, the open broker APIs as well. So all these kind of things needs to be integrated. So the only thing that we are trying to do is just bridging the gap between these things that already exist and Spring Cloud and adding more and more abstractions to Spring Cloud to support all these features. So,
Another thing that I'm interested in seeing how well it could work is perhaps getting Spring Cloud Gateway as an ingress, provider to Kubernetes and things like that. So, so kind of exciting. And we'd love your input on the things that you'd like to see and how useful it is to you.
That's pretty much it.
Sweet.
Yeah.
Questions?
Thank you very much for coming.
Yes.
Yeah.
So the question was, if my app is on PAS and I have apps on PKS, how do they talk together? Yeah, that's a good question that we're definitely interested in solving. There may be some integration with Istio that allows that if it's running on both sides. Yeah, we're in communication with the routing and network team on PCF. So it's not there yet, but I think it will get there.
It's coming, yeah, totally. Yep.
Any others? If not, thank you very much.
Thank
we
you,
appreciate, if you could give us feedback on the app, we'd appreciate it.
That would be
Thank
awesome.
you.
Thank you, guys.